Now let us see the case of distributing distinct objects into distinct boxes such that empty boxes are not allowed. Now here if we begin with the previous case, that is, if the empty boxes were allowed, then we know that for n objects and r boxes, we have total r raised to n ways of distributing. Now this is because for each object we have r choices to distribute, so therefore for n objects we have in all the multiplication of r n times, that is nothing but r raised to n ways. But now we have to subtract the total number of ways in which the empty boxes have been present. So therefore, if we use the principle of inclusion-exclusion, from r raised to n we have to subtract basically the number of ways or the number of cases where at least one box is empty. So that after subtraction we will be left with the cases where none of the boxes is empty. So now that is equal to r raised to n minus. Now when we think of the cases where at least one box is empty, that means it is either one box is empty or two boxes are empty or three boxes and so on. So if you want to think of the first case, that is say just one box is empty, so that means that one box can be any one of the r boxes, so that means it can be selected in RC1 ways. So therefore for the remaining r minus 1 boxes, there are in general r minus 1 raised to n ways to distribute the n objects. Now in this what has happened is we have double counted the possibilities where two boxes can be empty, because they will be definitely counted in this first particular term. So therefore we have to now subtract the cases of two empty boxes, so which can be selected in RC2 ways, and hence for the remaining r minus 2 boxes we have r minus 2 raised to n possibilities. So therefore continuing further, we will have the next term as RC3 into r minus 3 raised to n and so on. So this is where we have used the principle of inclusion and exclusion. So therefore on taking out the minus sign, that is on expanding, we get r raised to n minus rc1 into r minus 1 raised to n plus rc2 into r minus 2 raised to n and so on, up to in general the last term will be given by minus 1 raised to n minus 1 multiplied by rc r minus 1. So that's the total number of ways to distribute distinct objects into distinct boxes such that none of the boxes is empty.